Linear functions. Well, linear functions are probably the most common type of function that you guys are aware of. Okay? You've been doing these for a long, long time. Okay? The most common form that you guys have seen is this idea of y is equal to mx plus b, or in this case, we're going to have it written in function notation where we have ax plus b. Again, b is still going to be the y-intercept. A is going to be our slope. Okay? Again, nothing new here. Now, when we look at things, we want to usually put those things back into a function, right? We want to know what y equals. Well, the first one there is curious. Okay. Now, if I take a look at A, we have a bit of a problem here. I mean, B is pretty easy. I got the y, so I got that visual clue that, hey, y is equal to 5. I got xy is equal to 2, so that's not that big of a deal, so I can solve for y again. But we're going to start off here with A. And what we want to do here is we want to establish this as a linear function. That means that there's two possibilities. I could solve for t, and I can solve for s, correct? One of these has got to work. So if I'm going to go and solve for t, that would give me negative 2t is going to be equal to negative s plus 1, right? Divide by negative 2, divide by negative 2, so that gives me t is equal to, that would be 1 half s minus 1 half. Is that a linear equation? Okay. So in this case, is t a function of s? The answer would be yes, because t depends upon what s is. Let's try it the other way around for those of you not watching. And I end up here with s is going to be equal to 2t plus 1, right? Just bring the s over from the other side. Is this in the form of a linear function? No. This means that s is dependent upon t. So unless we're given more information, or we're given some more guidance, or we see a table of values, we don't know necessarily which one we're working with. Now, if you think that this is, not a realistic example, I want you to think of Fahrenheit and Celsius. We have an equation that goes from Fahrenheit to Celsius. We also have an equation that goes from Celsius to Fahrenheit. That way our Canadian friends can understand when we say how cold it is, right? Yes? No? But they're both functions. They're just written and solved for a different variable. So that's perfectly legal. Y is equal to 5. Well, we know that's a linear function. That's just a line that goes through it. 5. So let's try this one. If I want an equation, I have to solve for y. So what do I have to do to both sides? Divide by x. So that means that y is equal to 2 over x. Now my question is, does this fit the form of f of x is equal to ax plus b? And the answer is no. What is the exponent on this x up here? So if that's 1 up there, this down here, well, that's 1 down here. Problem is, if I try and make it look like that, I really get y is equal to 2x to the negative 1. Okay? so we don't get the same thing, right? So we've got to be very, very careful. Just because I can put it into a y equals situation, just because I can solve it, does not mean that I have the correct stuff. Okay? Anyhow, continuing on. Intercepts. Intercept. We always want to know where intercepts are. Got to kind of think of them like intersections. Always got to be careful. We got to know what's going on. I mean, after all, you don't want to be going into an intersection when somebody else is going into an intersection, because then you know what you have. Intercept. Bad. Don't want those. Now, there's a couple of ways that we can go through and do this. The most accurate way that we can go through and do this is always going to be algebraically. Although sometimes it's downright tedious, and there are quicker ways of dealing with it. But if I want to find an intercept, all we have to do is set x equal to 0, solve. Y is equal to 0, solve. Why? Because if we take a look at these coordinates, here I know that y must be 0. So if I plug in 0 for y and solve for x, it tells me exactly what the value is. Down here, x must be 0. I put 0 into the function and I solve it. I get exactly what I want. So, depending upon what you've got for an equation, kind of dictates as to what you can do. Actually finding slopes in this situation is, or not slopes, intercepts in this situation is a lot easier than if it's in y is equal to mx plus b form. Why? Well, easy enough. We know that we're going to have 0 comma something, right? And then we are going to end up having to have something comma 0, just the way it is. So if I put 0 in for x, well, that's going to be 2 times 0 minus 3y is equal to 12. Do I even have to worry about this? No, it's multiplication by 0. Anything times 0 is 0. So really all I got to worry about is dividing by -3, so y is equal to -4. Okay. Same thing over here. I put 0 in for y. I really only have to concern myself with the 2x is equal to 12. So what's x equal to? 6. No big deal. Plug it in, solve. Easy enough. Again, it's nothing that you haven't done in your younger days. Now, finding intercepts graphically. We can go through and graph out the equation and see where it goes through. Problem is with that, especially when you're drawing it out on a piece of paper, is you've got error in the way it's drawn out. Now, we can also do this with the calculator. So I'm going to go back here to this equation right up over here. Grab this. Well, what I should have here is this in y is equal to mx plus b if I'm going to put it into the graphing calculator, right? Turn that on, second. 72. Okay, so y is equal to. Now, I can kind of cheat a little bit when I do this, because I know that the 2x has got to go over, right? So I'm going to put parentheses. I'm going to put, it's going to be -2x plus 12 divided by -3. Will that get me to where I want? So I bring the 2x over, so I subtract 2x to both sides, then I divide by -3. Notice I didn't bother going through and trying to simplify a darn thing. it doesn't matter. In this instance, running it through like this is just as quick and easy. So if I graph it out, I get this. Now, the x-intercept, that's easy. Or correction, the y-intercept, that's easy. I put x in there, x is equal to 0, -4. I know that right off the bat, correct? Now, one of the other things that we can do with this, it's kind of a cheat, but I am going to do this. Y is equal to 0. And I'm going to tell it to graph. And you're going to see absolutely nothing change. Okay? And why did I do that? Well, I want it going through the x-intercept. I don't know what my value for y is, but I know y is going to have to be what? 0. So, I set that equation. What I'm going to do is I'm going to go up the second trace, and I'm going to go down here to number 5, intersection. Okay? So the first curve, it's just asking where first curve is y1. Enter. Second curve, y0. Enter, enter. And it'll go through and it'll do the math for me, and I find out that x is equal to 6. So the x-intersect is 6. It's kind of a cheat, but it works. There are other ways of going through and doing this as well, but this is one of them if I want to just use the calculator straight up. But the trace function will be able to do that too. Another way to go through and do it would be to go and use the table. I've got zeros in here. Okay? I've got a 0 sitting down over here, and I've got a 0 sitting up over there. They correspond to the coordinates that we want. Problem is, will we always have the intercept going through at a nice whole number? No. That's why algebraically is usually the best. Generally what I do is I'll put the equation in, graph it so I can see what's going on. I'll go to the table and see if I can come up with this, otherwise then I'll go and do things algebraically. It's just an order of how to go through and do that. So, let's see here. Slope of a line. Now this you guys should know like the back of your hand. y2 minus y1 over x2 minus x1. Rise over run. It's just one of those things that should be ingrained into your minds. So, okay. One of the things that we always keep in mind whenever we're looking at graphs, whenever we're talking about functions, whenever we're thinking about this, we always want to think of this in terms of going from the smallest thing to the largest thing, left to right. So when we take a look at graphs, we are always looking at it, what is it doing as it moves from left to right? So if it is going up, positive. If it's going down, negative slope. Horizontal line is going to be m is equal to 0. Vertical line doesn't have a slope. You know, rise over run. It doesn't have any run. It's not going to the left or right, is it? So that's 0. And division by 0 is? Division by 0 is undefined. Become one with this concept. All right, slope, intercept. We've talked about that before. Constant rate of change. It's kind of an oxymoron, but you do realize that the only constant in the world is change. Okay. And a constant rate of change is what we have here whenever we're talking with a line. M is always going to be a value that represents how much it changes from one to the next. That's all it's going to be. So, last one. Those guys. One of the things that I want to make sure that you guys have down is this idea. There's another way of having it, and it'll be coming up down the road a little bit more, but I want you to start thinking about it now in case you see it. There is something that is ax plus dy is equal to c. It's called standard form. Okay? There is a trick for dealing with slope, and since we're talking about slope, I want this to come out. In this case, you will notice that it's capital A, capital B, capital C. That means that there's very specific things. Okay? A, B, and C are not the same as C and A and B and something else. This case always is like this. Now, the other thing is that C is the constant, which is actually the y-intercept to a point, because I got to do the division. But what I want you to have here is this. Slope is equal to negative A over B. This is a nice little shortcut that if you see an equation that is written in that form, that's what the slope is always going to be. Now, if you do the algebra in your head, you move the ax to the other side, that's negative ax over there. Then you divide by b, so it'd be negative a over b. But it's handy to have that little piece of information as we go through and work on things. So, with no further ado, I am going to let you guys get to work on this.